Good morning, children. Welcome to chemistry class. So, already we are seeing electron cloud repulsion theory in discussing about the structure of the molecules. So, in that, as per the one postulate, when there are no lone pair electrons with the central atom, so all the bonds are having means equal angles, and as per theory we can say it is 360 divided by number of bonds. But when we observe methane, right, where here C valence is 4 electrons, and these 4 electrons are like bonding with the 4 hydrogens, so therefore there are no lone pair electrons here, no lone pair electrons. Then they should be like 90 degrees of the angle. But here the angle is practically observed to be 109 degrees 28 minutes. The reason for this is the hybridization. So this concept we are going to learn already. Some of you know it very well when we have studied like foundation IIT foundation classes. And for the regular children, after this theory, then, like at the end of this chapter, we are going to discuss about the hybridization and how the valence bond theory is applied for the hybridization. So here sp3 hybridization takes place, and therefore the bond is between the sp3 hybrid orbitals. Thus the structure of methane is tetrahedral. It is not like a planar structure, it is of tetrahedral structure. Okay. So then next, when we move on to the ammonia. So here there is one lone pair of electrons, and the remaining are all bond pair electrons. With the central atom, since there is one lone pair electron, based on this theory we can explain it to be, right, this lone pair of electrons occupy more space when compared to the bond pair electrons. Therefore these are pushed, and hence 107 degree 48 minutes is the angle. Not only this, even based on hybridization also we can explain this phenomena. And coming to the water molecule, so here there are two lone pair electrons with the oxygen, and the remaining are the bond pair electrons. Oxygen is a central atom, and because of this they occupy more space, right, and hence the angle here is 104 degrees 31 minutes. So this is how we can discuss the theories, like for how the molecules are formed based on covalent bonds and all that, right? And then in this one, so VSE PRT theory, so based on this theory, this is the explanation that we can give. And now coming to this is very important point. Of course anybody will write this one. So what is the bond angle? Means it is the line joining the nucleus to the nucleus of the other atom which is in bond. So that is the angle made by the bonds, right? So if angle subtended by two imaginary lines that pass from the nuclei of the two atoms which form the covalent bond with the central atom through the nucleus of central atom at the central atom. So this is how we write the bond angle. Now coming to VSE PRT theory. It is not much different from Lewis dot structure theory. And what is the other drawback that we have here is that it could not explain the strengths of the bonds. Which bond is stronger, why it is stronger, and which bond is not so strong enough. And as well as this one also, methane, why is the angle 109 degrees 28 minutes. All these are not being explained by VSCPRT theory. So thus we will move forward to the next theory, what we call it as valence bond theory. So before we move on, just take the screenshot of methane molecule, and then ammonia, then water molecule. So now let us see valence bond theory. So after the previous theory, we are coming to valence bond theory, where in previous theory it is the repulsion between the electron clouds, where valence bond theory explains like this. Whatever the bond which is formed, that is a covalent bond, is formed because of the overlapping of valence shells. And those valence shells also have the electrons with opposite spin. So here if you observe the hydrogen here, so one particular hydrogen atom is having a spin in upward direction, anti-clockwise direction, and the other one is having in clockwise direction. So here both the shells are overlapped, and thus we have both the electrons to be in that overlapped region. So this is the first postulate of valence bond theory, that the covalent bond is formed because of the overlapping of valence shell, where those shells have the electrons with opposite spin. So next one is, the greater the overlapping, the stronger will be the bond. So the more and more they come closer, and then the overlapping is more, then the bond will be stronger. And this also, this overlapping or the strongness of the bond also gives the directional character to the bond. So when will it give the directional characteristic? That is, other than s orbitals. If the overlapping orbitals are other than s orbitals, then that overlapping gives the direction of the bond. Because you have px, py, pz, isn't it? The directions are mentioned, whereas s orbital is a spherical orbital. So there is no point of having a direction at all. But whereas when the overlapping takes place with the p orbitals, so you know they are of dumbbell shaped, and then x, y and z axis along. So thus we have orientation of this overlapping. So that means the overlapping, because of this overlapping, other where the participants are other than s orbitals, then some direction sense is given to the bond. Okay, so now these overlapped orbitals are shared by both the atoms. This is what valence bond theory says. And previously we were talking about the electrons being shared by both the atoms, or they belong to both the atoms, and here the overlapped orbitals belong to both atoms, right? When multiple bonds are formed, then usually, suppose it's not only one bond, you have seen the other cases also where there are not single bond but many bonds are formed. So when multiple bonds are formed, usually whenever the overlapping is along the nuclei, along the line joining the nuclei, right, that is called nuclear axis, then first bond is formed between those two, and that results in sigma bond. The kind of the bond formed is called sigma bond, and it is very strong, and the next bonds which are going to be formed are laterally, means sidewise bonds are formed, and these are called pi bonds. These are called pi bonds, and these are weak when compared to sigma bonds. Let us see one example, that is of chlorine molecule. So what is the electronic configuration of chlorine? 1s2, 2s2, 2p6, 3s2. Now coming to third shell, you have completely filled s orbital, and px, py are also completely filled. Now we have only pz with only one electron. So now here the bond will be formed with, of course, pz. So therefore one chlorine atom if you take, then the 3p orbit. So here this is the pz, which is having only one electron with one spin. And if the chlorine has to combine with the other one will be having opposite spin. And these two are combined together to form, that means these shells are overlapping each other, and in this overlapped region you have both the electrons, and thus this is how the chlorine molecule or chloride molecule is formed. This is how the chloride molecule is formed. So here what are the orbitals which are participating? P orbitals, not the s orbitals. Whereas in case of hydrogen, just now we have seen, you can see the orbital shape, that is spherical. Is it not? So spherical, here two spheres are overlapped, and here you have two dumbbell shaped are overlapped. Okay, see children, so take the screenshot, prepare your own notes. Also, please give a reading from your textbook. It is totally theoretical. So every point is important. When you read from the textbook, you will come to know what are the important points. So take the screenshot of this valence bond theory. We shall see other examples also, like nitrogen molecule. These are the properties or the postulates of valence bond theory. And fluorine molecule. And now this is of nitrogen molecule. So when you look at the valence, the electronic configuration, complete second, the first orbit, first shell is totally filled, second shell. When it is coming to second shell, so what is the valency? First of all, 2 plus 3, 5. So s orbital is totally filled. Now you have px, py, pz. All three are having only one electron with each other. So when two nitrogen molecules come together, so this is the px, this is the px orbital, this is the py orbital, and this is pz orbital. As you have x, y and z axis of the coordinate system, similarly you have, this is px, py, vertical is py and inclined is pz here. And when two nitrogens are brought closer to each other, so therefore now px is along the axis of the nucleus. So therefore there is a sigma bond formed between px. So therefore sigma px bond is formed. And in laterally, sideways py bond is formed and pz bond is formed. So please children, observe the green line. This is between the two y's. And observe the red line. This is between the z's. So this is one pi bond with py's and another pi bond with pz's and a sigma bond between px. So this is how a nitrogen molecule is formed. And oxygen, you can draw by yourself the oxygen molecule. So here if you have one sigma bond will be formed between py's and one pi bond will be there with the pz. So why? Because see here first shell is totally filled. In second shell s orbital is totally filled. Px is also totally filled. And here the valency is py and pz are having only unpaired electrons, single electrons. So here py will have sigma bond and pz will have a pi bond. So this is how an oxygen molecule is formed. You can draw a diagram and post, as well as you can just draw it in your classwork so that it may help you in preparing for the exam. Okay. So valence bond theory also is not completely satisfactory to understand all the kinds of the bonds here. And thus we are moving forward in the next class with valence bond theory and hybridization. Only valence bond theory without hybridization, if we discuss, it is something like discussing only few cases. To generalize it, we need to know hybridization. So in the next class, we shall discuss hybridization and how valence bond theory is applicable in case of hybrid orbitals. Okay children? So take the screenshot of this.